A sample of tin is analysed in a time-of-flight mass spectrometer. The sample is ionised by electron impact to form 1+ ions. Table 1 shows the data of 4 peaks in the spectrum. Give the symbol, including the mass number of the ion, so I need the charge as well, that reaches the detector last. So the one that's going to reach the detector last is the one with the greatest mass, or the greatest MZ, which is going to be this one. So it's 120. The chemical formula for tin is SN, and we're told up here that it forms a 1+ ion, so I need the plus charge on there. Part B, give the relative atomic mass of tin in this sample, giving your answer to 1 decimal place. So I'm just going to give myself a little reminder here. This is exam technique. That when I finish my calculation, that's what I need to do. Now I'm given 3 percentages and 1 that I need to work out. So it's going to be 100. So to work out the percentage abundance here, it's going to be 100 minus 22.41, 11.78, 30.84, and that equals 34.97, and that will be one of the 3 marks that we have here. Now using the formula, relative atomic mass is equal to, so 112 times 22.41 plus 114 times 11.78 plus 117 times 34.97 plus 120 times 30.84, all divided by 100 because it's the total abundance and percentages are out of 100. So there'll be 1 mark for the working there. And then the AR is equal to 116.4513. So to 1 decimal place, that means I need to round that up. So that is 116.5. Okay, so if you got the answer right, you'll get all 3 marks, but it is a risky move because if you've got the answer wrong because you've typed something in your calculator from this quite long expression here, if you get the answer wrong, you lose all of the marks if you haven't shown your working out. Okay. C, state in terms of numbers of fundamental particles, that's protons, neutrons, electrons, 1 similarity and 1 difference between atoms of 112 and 114 tin. So they have these are isotopes, so the same number of protons. You may have said that they have 50 each, is fine, and different number of neutrons. And again, you may have said that one's got 62 and one has got 64. Part D, explain how the sample of tin was ionised in the time-of-flight mass spectrometer. It tells you in the question that it was done by electron impact, so we need the explanation for that. So we need to speak about high energy electrons fired from an electron gun, so that would be one of the marks. You're told they form 1+ ion, so knocks off 1 electron. You could use the formula here, so M gas goes to M+ gas plus E-. Okay. And then E, a calculation. So 112 tin plus ion travels along a flight tube, length 1.25 meters. The ion has constant kinetic energy, and we're given the formula there. We're told that M, the mass of the ion, needs to be in kilograms, and V, the speed of the ions, in meters per second. Calculate the time, so I need to work out the time. So velocity is distance over time, so time is going to be distance divided by velocity. So I've got distance, but I haven't got velocity. So I need to rearrange this to get velocity. And of course, my mass here, I need to times that by divide that by 1,000 to get it into kilograms. To get that into kilograms, and then divide by Avogadro's number. So quite a lot going on here. So let's do the mass of the ion. So that's 112 divided by 1,000 divided by Avogadro's number. and that equals 1.8598 times 10 to the minus 25, and there'll be a mark for that. And then I need the velocity to get it into the t, so I need to get the time of flight. So I need to rearrange the velocity and kinetic energy equation. So if I rearrange that, I get 2ke over m, and I've just worked out m. So that is, let's put those numbers in. So 2 times 2.5 times 10 to the minus 13, that's what I've got in the question, divided by m, which I've just worked out, 1.8598 times 10 to the minus 25, and that gives me a value of 1639632 meters per second. So to get t now, it is the distance, 1.25, divided by the time, divided by velocity, 1639632, which gives me 7.62 times 10 to the minus 7. So here's where the marks are. So one for working out the mass of the iron, one for rearranging the velocity, one for getting the correct value for the velocity. Common error here is you forget to do the square root part, and then 1 mark for working out the time of flight.